Okay, moving on. We next have Cruz from biochemistry at UW-Platteville, presenting on virus reduction from surfaces using first contact polymers. Begin.
All of you watching these pitches today are probably sitting at home behind a screen or at work or school because of the global COVID-19 pandemic. What if I told you that a chemical polymer called first contact could contribute to ending the pandemic? Hello, my name is Cruz, and I've been researching the effectiveness of first contact at removing viruses from surfaces. I decided to do this because first contact, invented at UW-Platteville, is an adhesive polymer already known for being able to remove fingerprints, bacteria, and even DNA from surfaces. Because of this, it seemed like a logical hypothesis that viruses may also be removed with first contact. We are performing this research in coordination with the Planetary Protection Division at NASA's Jet Propulsion Lab, who is interested in first contact's ability to clean equipment by removing contaminants from returning spacecraft. COVID-19 is just one of the many things that falls squarely within this category of undesirable contaminants. First contact is a liquid adhesive that we apply directly to the surface being cleaned. When the solution dries, it is simply peeled away from the surface. Doing this removes contaminants from the surface through adhesive forces. One benefit of this is that we have the ability to later retrieve samples from the first contact that has been peeled off. The result is both a cleaner surface than the current cloth-based systems and an opportunity to further study the isolated contaminants from the peeled first contact under safe laboratory conditions. My goal is to determine the effectiveness of first contact for removing viruses from surfaces using a laboratory virus as a substitute for COVID-19. These viruses have a long history as model specimen for basic science research. Based on the results of previous experiments we have conducted with bacteria as well as DNA, we feel confident that first contact will be effective for removing viruses. Our current efforts are focused on creating protocols based on the ones used with bacteria to accommodate the differences between them and viruses. These procedures are being developed to remove the viruses from glass surfaces, although we have plans to broaden the range of our research to other typical industrial and household surfaces, such as stainless steel and porcelain. It's not hard to imagine a time when first contact sits next to Lysol on the shelves of grocery stores. Overall, we are working diligently on demonstrating first contact's ability to remove virus from surfaces because, as we've seen over the last year, we will not always know when a devastating illness will appear, but the better equipped we are, the better off we will be, and first contact could soon be our first line of defense. Thank you.
Thank you, Gene. Any questions from the judges?
Gene, what do you do with this material once it's peeled back from the surfaces? How do you decontaminate it or dispose of it at that point?
Right. So we actually, you just dispose of it as in a waste bin as anything else. Obviously, you want to be careful in case there are contaminants with it. Yeah.
Gene, just curious, so using a rag is easy, right? How much more difficult, or is it the same to use this type of adhesive?
Right. So in the lab, we apply it directly using a simple pipette onto surfaces. Although it has been theorized, and it's a possibility that application through aerosol, similar to Lysol, is possible. And well, we know that it's possible. We just don't use it yet. So that's one application to make it simpler for people to do.
Thank you.